Hey everybody, this is going to be a quick introduction to the next chapter. I mentioned in class that the next chapter is not extremely long. In fact, we'll be able to get done with it by the end of the semester. So we've got just a couple weeks to do that, but it's going to be just fine. So we'll get through the first idea. Just going to be basically adding fractions together, and you'll be just fine with that. And then I'll have a follow-up to this one that you can put off until over the weekend, and we will get a nice head start on the rest of this chapter. So here we go. We will start by looking at quickly just adding fractions. It is going to get more complicated than this, but I just thought I'd remind you that if I'm adding two fractions like 5/12 and 7/12, if they already have the same denominator, we're in business. 5/12 plus 7/12 is 12/12. And of course, 12/12 is just 1. The idea being if the same denominator is already there, no worries. If I don't have the same denominator, I can go through a manipulation. I can say that um, 6 is a factor of 12. So if I multiply 6 by 2, that would give me the same denominator. But of course, I can't just do that because I've just changed the value of that second fraction. So instead of just multiplying by 2, I'll multiply by 1. Multiplying by 1 is legal because it doesn't change the value. And in this case, multiplying by 1 in the form of 2 over 2 will give me that same denominator. So now I've got 14/12. And so I can add those together. 5/12 plus 14/12 gives me 19/12. And in this case, that doesn't reduce. No factors in common, so that would be my answer. Leave your answer as an improper fraction, please. I don't want to see mixed fractions. And it's not going to be much of an issue anyway. And finally, if there are no common factors in the denominators, they're not both even, one of the numbers is not a factor of the other, I'll just have to multiply both of these fractions by some um, version of 1. If I want to have a factor of 5 in the denominator, I'll just have to multiply by 5/5. If I want to have 7 as a factor in the denominator, I'll just multiply by 7/7. Once again, what I'm doing is illegal because I'm just multiplying by 1. Multiplying by 1 doesn't change anything. So now I've got 84 35ths plus 30 35ths. So common denominator, let's go ahead and add those together. I've got 114 35ths. If I have a common factor, I could do some division. The only factors of 35 are 7 and 5. 5 definitely doesn't go into 114. I don't think 7 does either. So it looks like that is it. Now, what we're going to be doing is not adding fractions with just numbers. What we're going to be doing today at the start of this next chapter is adding and subtracting rational expressions. Now, just in case you don't know what rational expressions are, it's just a fancy way of describing fractions where instead of numbers, I've got polynomials. So the three expressions that you see on your screen right now are rational expressions because both the numerator and the denominator are polynomials. And at least for today, they'll be a little bit simpler than what you see right there. So, analogous to what we just did with the numerical addition of fractions, if I have two rational expressions and I want to add them together, and the denominator is already the same, great. You just have to add them together. I'm going to get something over x plus 5. And the something that I will get is what happens when I add these two together. I've got x minus 7 plus x plus 17. Well, combine like terms. X plus x is 2x. Negative 7 plus 17 is 10. And in the case of something like this, if there's a common factor, we should cancel it out. And here we actually do have something that is going to simplify. 2x plus 10, I can factor a 2 out of that. I wouldn't necessarily do this, except I see that the other factor, if I take out 2, is x plus 5. And x plus 5 divided by x plus 5, that's going to cancel out. And I'm left with just 2. Not all going to simplify this much. In fact, this is kind of a rare case that simplifies like that, but this one does, so I did. Couple more examples. Here's an example that is similar to the second one I did. One of the factors of 12 is 6. So I didn't have to multiply by 12 over 12 and 6 over 6. I could just multiply by 2 over 2 to get that common denominator. Same thing here. I already have an x minus 7 in the denominator, so I don't need to multiply by x minus 7. It's already there. But in order to get that x plus 2, I will have to multiply this first expression by x plus 2 over x plus 2. So once I've done that, in the first fraction, I've got x plus 2 times 5x. So I've got 5x squared plus 10x. In my second fraction, I still have just the 3x. It's still over x plus 2 times x minus 7. And I'm kind of regretting doing this on my mouse. I think for the next video that I will make for the assignment over the weekend, I may just do that one with the document camera using a paper and pencil to speed up this process a little bit. Anyway, once we do that, I still have the same denominator. Now that I have a common denominator, I can add these two fractions together just by combining like terms. 5x squared is the only x squared term, and 10x plus 3x is 13x. Now in this case, I suppose I could factor an x out of that numerator, but that doesn't cancel out with anything in the denominator. So in a case like this, I probably just leave this one as is. Factors of the denominator are not factors of the numerator, and so there would be no cancellation. So I will leave this one as is. Moving right along, I've got two more examples to do. The only reason I wanted to do this example is because a minus sign is something to watch out for. Subtraction isn't a huge deal, but there is one common mistake that I'll talk about once we get to that point. I'll start by doing what I did on the previous one. I'm going to multiply by x minus 2 over x minus 2, just multiplying by 1 as I've been doing. Now I've got the same denominator. And so maybe I'll just do it like this. My denominator is x minus 2 times x plus 5. By the way, if you want to expand that, go ahead. I don't really care, and so I'm not going to do that. I've got 7x squared minus 2 times 7x, so minus 14x. And here's the tricky part. There's my first numerator. I'm subtracting my second numerator, and here's where people make a mistake on something like this. I'm subtracting that whole thing, not just the 3x. And if I don't use these parentheses, I may forget that I'm subtracting 3x and I'm subtracting negative 5, and that minus negative 5 is going to become a plus 5 once I get to my final answer here. And so denominator, x minus 2 times x plus 5. And my numerator is, let's see, the only x squared term is 7x squared. I've got a minus 14x minus a 3x, so minus 17x. And then minus negative 5 to give me a plus 5. I'm a little bit worried that one of these might be a factor, that x plus 5 or x minus 2 might be a factor. So if you're really concerned about simplifying, you could send negative 5 through synthetic division and see if that works out. I don't believe that's going to be true for this one. I'm going to say that the factors of the denominator do not match any factors of the numerator, which means that is my simplified answer. And one last example for us to go through works pretty much the same way, but in this case, what we have is that none of the factors of the denominator of the first fraction match any of the factors of the denominator of the second fraction. So I'm going to have to multiply the one on the left by x plus 2 to get a factor of x plus 2 in that denominator. And then to get a factor of x in the second denominator, I will multiply by x over x. So now my denominator is x plus 2 times x plus 2 times x. Now I've got the same denominator. That denominator is x times x plus 2. If you want to call that x squared plus 2x, go right ahead. I'm not going to stop you from doing that. Leaving my my denominator in factored form is actually kind of beneficial to me. My first denominator, I'm going to go ahead and FOIL this out. 2x times x to give me 2x squared. I've got plus 4x plus 3x to give me plus 7x. And then plus 2 times plus 3 gives me plus 6. There's my first numerator, and then my second one is 3x times x. That's just 3x squared. And so finally combining my like terms, x plus 2 times x, I'll leave that in that form, and 2x squared plus 3x squared gives me 5x squared plus 7x plus 6. Once again, I'm a little concerned that x plus 2 might be a factor, so I could send -2 through synthetic division and see if it works. I do not believe it's going to work in this case, and it is certainly not what I'm trying to emphasize with you as we go through these problems. So the first assignment, the day one assignment from the radical chapter, if you're looking at this on Wednesday and you're more worried about the test tomorrow, that's fine. I understand. You can certainly procrastinate a little bit, but if you do procrastinate, don't forget about this one over the weekend. You'll end up with 2 assignments over the weekend. And so, well, you can still work on it at that point. But you'll see questions that are similar to this. And yeah, there we go. I've got one more video to make for you. We'll cover what you're doing over the weekend. So end this one and start that one.